So first question, y equals square root of x has been translated. So they've already told us it's a translation onto the curve y equals x, the square root of x plus 4. This one is just a knowledge question. So we've gone from f of x essentially to f of x plus 4. So we know that when the transformation affects the x, we do the opposite. So it's going to be this one here. Any questions about that one? And just to double check, can people see my screen?
Yes.
Yeah.
Awesome. Okay. I am going to try and move through quickly, but if people want to ask questions, then please stop me. I will stop. I'm just going to go through quickly just for the sake of time, because I realize this is a long paper. So yeah. Right. Second one, the imply statement. We're essentially saying that for one statement to be true, the other has to be true. So if we look at these two statements, we can't, it's going to be this one. A is implied by B, or B implies A, because for A to be true, B has to be true. If B isn't true, then we can't have A be true. So because it definitely goes that way around, the arrow has to at least point to A. And just to check if it points to B, well, the solutions for this factorizes to x minus 2, x minus 4 is greater than 0. And by drawing a little graph, we can see that either x is greater than 4 or x is less than 2. So because using A's statement, that can tell us many different things. That can tell us that x is greater than 4, but it can also tell us that x is less than 2. So it's not going to imply B. But B definitely would imply A. Hopefully that makes sense. And hopefully when we went through, when I went through like people's different groups in the breakout rooms, they were able to make sense of this question. But we'll have more questions like this as we do more papers. Okay, so here we've got the square root of 3 is just 3 to the power of a half. So therefore P is equal to half. So that's part A, part 1. A part 2, 1 over 9, well, that's 3 to the power of minus 2. So therefore Q equals minus 2, using laws of indices. With this one, well, we've got the square root of 3, which is 3 to the power of a half, times 3 to the power of x equals 3 to the power of minus 2. And then we just use that to solve. So if we divide both sides by 3 to the power of a half, that gets us 3 to the power of x equals 3 to the power of minus 2 divided by 3 to the power of a half. When you're dividing, you take away the powers. So that gives us 3 to the power of x equals 3 to the power of minus 2. Take away a half is minus 2.5, or minus 5 over 2. So therefore, x is equal to minus 5 over 2. Okay, if there are no questions, I'll keep it moving. This one, nice surd type problem. So it's rationalizing the denominator. So, I've not written that correctly. We've got 5 root 2 plus 2 multiplied by 3 root 2 minus 4. And that's all over 3 root 2 plus 4 multiplied by 3 root 2 minus 4. Any questions as to why we are multiplying by 3 root 2 minus 4? Okay. So when we expand the top part, we get 5 root 2 times 3 root 2. Well, 5 times 3 is 15. Root 2 times root 2 is 2. 15 times 2 is 30. Then we have 5 root 2 minus 4, which is minus 20 root 2. Then we have 2 times 3 root 2, which is plus 6 root 2. Then we have minus 8 over, and then we have 3 root 2 by 3 root 2, which is 9 by 2, which is 18. And then the middle terms are going to cancel. So it's actually going to be 18 minus 16. We'll notice that this is a difference of 2 squares. So this bottom bit resembles a minus b, well, a plus b, a minus b, which expands to a squared minus b squared. So I can expand that to say 18 minus 16. So then that becomes 30 minus 8 is 22. Then you have minus 20 root 2 plus 6 root 2 is minus 14 root 2. And that's all divided by 2, which simplifies to 11 minus 7 root 2. So we have the m equals 11, and we have the n equals minus 7. And because it says show that, you have to actually go through these steps. Some people might be thinking, but it's a calculator paper. Surely I can put this in my calculator. You can, but you haven't shown how you've gotten to that step. The calculator will just give you that. Just so that I can get a show of voices, how many people are on board and are okay?
Yeah.
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 Cool.
Yes.
Yeah.
Awesome.
Yeah.
Yeah.
Lovely. I'm going to keep checking in with you guys just because I know it can be hard with like watching, listening, and taking it in. So if people have questions along the way, then please stop me.
So
Yeah.
I just did 5 root 2 plus 2 just times the 3 root 2 plus 4.
So the problem is if you do that, Larry, when you if you multiply the top by 3 root 2 plus 4, then you also multiply the bottom by 3 root 2 plus 4. And the problem with that is when you do the expansion, the bottom will still have square roots and stuff at the bottom. The bottom will still have square roots, but you don't want there to be any square roots. So by multiplying it by 3 root 2 minus 4, the bottom part ends up being an expression without any square roots. Does that make sense?
Yeah. No, I thought it was so much easier than that, so I just did it in my head.
Okay. Yeah, so it works out to be like this. Cool. Number 5.
Wait, do you have to write that m equals 11 and n equals minus 7?
No. You don't have to write that.
Okay.
You don't have to write that bit. The only time you have to write it out is when it says where m and n are integers to be found. When it says to be found, that's when you've got to state what they are, but otherwise, no. Keep the questions coming, guys. It's really good. Okay, so Jessica, a math student, is asked by her teacher to solve the equation tan x equals sin x. Don't worry, Jess, we know it's not you. You'll do better than this, Jessica. So we've got these steps, and the problem with what this person has done is this, from going from this point to this point, they've divided by sin x. And the problem is you can't divide by sin x because there's a potential for it to be equal to 0. And by doing that, she's actually gotten rid of solutions. So cannot cancel sin x. This gets rid of solutions. Ooh, I can't even write onto the, I thought I could write off the page. So, and then we can also say, you know, she is missing the solution from sine x equals 0, because that's one other solution. And of course, one of the solutions is that x equals 0, but also x equals 180. By saying that, that's going to guarantee your 2 marks. You're not only saying what the solution, what the mistake is, you're probably going on to say, okay, what should have happened, what she's missed out. I would personally write all of this for the whole 2 marks. Okay.
Wait, so sir,
Mm-hmm.
if you were to do that question, how would you do it without and still get the cos x equals 1 if you're not allowed to cancel sine?
So a better way to do it, I'm going to write it here in red. So we have sine x equals sine x cos x. Better way to do it is to take away sine x from both sides, maybe. So you can say 0 equals sine x cos x minus sine x. And then 0 equals sine x, open bracket, cos x minus 1. That's just factorizing out sine x. So the best way to do would be to factorize sine x rather than divide.
Okay, that makes more sense.
Yeah, and this is true of any other type of equation, where if you have the option to divide versus factorize, I'd probably prioritize the factorizing. Cool. Right, next one. This one I know tripped up a lot of people, including me when I initially looked at it. I thought, oh, okay, no, I can't do it this way because it involves things that are too complex. So, parallelogram. This is my attempt at drawing a parallelogram. I know you guys had really, really beautiful parallelograms drawn. And yeah, mine's just not going to top that. Sorry, guys. We've got alpha, and we've got the lengths 6 centimeters and 4.5 centimeters. The key here is realizing that you can actually split this into 2 triangles this way, identical triangles. So of course, this will be alpha 2, and this will be 6 centimeters, and this will be 4.5. And you can use the half AB sine C formula. So a half times 4.5 times 6 times sine of alpha is equal to, well, not the full area, but half the area. So 24 divided by 2, which is 12. So you'd end up getting, okay, what's 6 times 4.5 is, this is I'm going to need help from people because I don't know, 27 over 2, maybe.
Yeah, it's 27 over 2.
Okay, good. And then, thank you. And then we've got sine alpha equals 24 over 27. The halves will cancel, and then dividing by 27 will give you that. Then we want to work out the exact value of tan alpha. So at this stage, we're not going to take inverses and work out alpha. You never do that. The way in which you would do this, or one way in which you can do this, is use identities. So if we want tan alpha is going to be equal to sine alpha over cos alpha. Problem is, we don't yet have cos alpha, so we can first of all work out what cos alpha is. Well, recall that cos squared of alpha is equal to 1 minus sine squared of alpha, using our identities, which means that cos squared of alpha equals 1 minus sine squared of alpha, which is 24 over 27 squared. By the way, this can be simplified to 8 over 9. So 8 over 9 squared, which means that cos squared of alpha, by just combining the fractions, well, 8 squared is 64 over 90 over 81. So to get from 64 to 81, that's going to be 17. So that's going to be 17 over 81. And then cos of alpha equals the square root of 17 over 81, plus or minus. Question is it going to be plus or minus? Well, based on the question, and it says that the larger interior angles of the parallelogram are alpha, that means it's going to be obtuse. So that means that alpha is in between 90 and 180. And if you take cos of an angle between 90 and 180, I'll just do a little sketch of the cos graph. Then it's going to be negative because that's this region here. Between 90 and 180, it's below the x-axis. So therefore, cos of alpha is going to be minus the square root of 17 over 81, which is equal to minus the square root of 17 over 9, taking the square root of 81. So now we have that tan alpha equals 8 over 9, which is sine alpha, divided by minus square root 17 over 9, which is going to be minus 8 over square root 17. That is sufficient as an answer. You could rationalize it if you want to, but that is fine as an exact answer.
Sir?
Yep.
We did this in like a completely different way, but I did still get negative 1.94, which is what that is.
Yes. So the negative 1.94 is not exact, right? That's rounded.
Well, yeah. Oh, yeah. True.
Yeah. So the problem with doing it, because I'm guessing the way you did it was by taking inverses and working out what alpha was and putting it into tan.
Sort of, not really. We just took like a triangle using the height,
Mm-hmm.
and then we used SOHCAHTOA to find the smaller angle.
Mm-hmm.
And then we took those away from 360,
Mm-hmm.
and then divided that by 2 to get the alpha, and then we inversed.
Okay. Yeah. So the problem is you're not allowed to inverse, basically.
Oh.
Yeah. Because by taking the inverse, you end up losing accuracy because your calculators will only give you so many decimal places. Even a really good calculator, even if it gives you, say, 100 decimal places, that's not exact.
But even though there's no recurring or anything, it just stops at, this one stops at 6 decimal places. So is that not right?
Yeah, because I don't know why the calculator stops at 6 decimal places, but we know that it definitely wouldn't stop at 6 decimal places because we've got the square root of 17. And the square root of 17 cannot be expressed as a decimal, as a nice decimal that has a repeating pattern.
So would we get any marks for getting that answer because it's not exact?
Unfortunately, you wouldn't, which is really, really harsh of this question.
That's so
when they ask for exact, you really have to go through the motions.
Okay.
Of doing this.
Okay.
Yeah. You have to kind of be strong with your identities for this question. This was, to be fair, this is like a tough 4 marks. There are other ways of using the fact that sine alpha equals 8 over 9 to work out that cos alpha equals minus 17 over 9. But this way just uses what we already know. Cool, moving on. Determine whether the line with equation 2x plus 3y equals 4 is parallel to the line through points with coordinates 9, 4, 3, 8. Okay, so let's work out first of all what the equation of this line is going to be. Or we can work out the gradient for this one. So that's going to be, let's go 8 minus 4 over 3 minus 9, using the y2 minus y1 equals over x2 minus x1 formula, giving you 4 over minus 6, which is minus 2/3. So we have y equals minus 2/3 x plus c. And then we can use either point we like. So I'm going to sub x equals 3, y equals 8. So we have 8 equals minus 2/3 times 3 plus c, giving us 8 equals minus 2 plus c. Therefore, c is equal to 10. So this equation ends up being y equals minus 2/3 x plus 10. Then with the other equation, I'm going to write it in a different color. Wait, that is not a very good color to see, is it? I'm just going to purple maybe. Oh no, I've got more colors. Let's choose a dark-ish color. So we've got, oh, that's not the color I wanted. That's the color I wanted. So we've got 2x plus 3y plus 4 equals 0. And then if I were to make y the subject, I get 3y equals minus 2x minus 4. Dividing by 3, I get y equals minus 2/3 x minus 4/3. So we get that the gradient of both lines is minus 2/3. And by the way, this you have to write this statement. Therefore, they are parallel.
Sir,
Yeah.
do you have to find the C for the graph with the coordinates because it's just talking about gradient?
To be fair, yeah, upon thinking about it, you don't actually have to. You've established that the gradient of this line is minus 2/3. So to be fair, you don't actually have to work out C.
Okay, so you won't lose a mark if you don't put the C.
Yeah, no, you wouldn't actually. Yeah,
Okay.
I just thought about it just as you mentioned it. So thanks for mentioning that. You've basically found a more efficient way of doing it than what I just did. Yeah, by simply determining the gradient and the gradient of this one, that's actually sufficient. Very, very good point there. Thanks for spotting that. Ooh, binomial expansion. Okay. So we've got 1 minus 2x, which I'm going to rewrite as 1 plus minus 2x to the power of 10.
So, sorry,
Yeah.
can we just go back to the other one?
Mm-hmm.
Because I got one gradient is minus 2/3,
Mm-hmm.
and the other one is just 2/3. I did
Which one did you
the
get as
gradient. Sorry?
So which one did you get as 2/3?
Oh, wait. So I did. Okay, never mind. Sorry. Thank you.
That's all good.
I had to look back.
It's all good. That is absolutely fine. But again, the more questions you ask, the more you'll gain. So it's all good. So with this one, 1 plus minus 2x, all to the power of 10. They're asking us to find the first three terms. So that's what we're going to do. We can use the choose button to do this question. So we can say 10 choose 0 times minus 2x to the power of 0 times 1 to the power of 10. This is just using the formula. I'm not doing anything fancy here. Plus 10 choose 1 times minus 2x to the power of 1 times 1 to the power of 9 plus 10 choose 2 times minus 2x to the power of 2 times 1 to the power of 8. Notice how the powers are always adding up to 10, the original thing there. This first bit simplifies to 1 because 10 choose 0 is 1, minus 2x to the power of 0 is 1, 1 to the power of 10 is 1. Next bit, we get minus 2x. Oh, wait, no, that's a lie. Sorry. That's a lie. 10 choose 1 is going to be 10. And then you've got minus 2x is going to be minus 2x. So that's going to be minus 20x. The second part, if somebody could be so kind as to tell me what 10 choose 2 would be. 45 maybe?
Yeah, 45.
Yeah. Okay, thank you. And then 45, and then you've got minus 2 squared is positive 4. So 45 times 4 is going to be 180. So that's plus 180 x squared. And that's the first three terms in ascending powers of x. Okay. Carly has lost the calculator. She uses the first three terms in ascending powers of x to find the expansion of 1 minus 2x to the power of 10 to evaluate 0.998. Find Carly's value of 0.998 to the power of 10 and show that it is correct at 5 decimal places. Well, we've got to pretend that the bit inside the bracket is equal to 0.998. So the 1 minus 2x equals 0.998. I really say pretend. We've got to say that it is. So we'd get that 1 minus 0.998 equals 2x. Then that would give us, what's that, 0.002 equals 2x. Therefore, 0.001 equals x. So now that we've worked that bit out, we're going to substitute that into our expansion. So our expansion was 1 minus 20x plus 180x squared. So sub x equals 0.001 into 1 minus 20x plus 180x squared. And when you substitute it in, that's going to give us the approximation. I do not have a calculator, so if somebody could be so kind as to work out what that is, please.
The full thing.
Yes, please.
I got 0.98018.
0.98018.
Yeah.
Is that, oh, it just gives you that. Lovely. That's assuring because it says that show that it is correct at 5 decimal places. This is 5. 1, 2, 3. Yeah, this is 5 decimal places. Hesitated there with the counting. Any questions about that?
1 second, wait.
Mm-hmm.
Why was it 180?
Why was what 180, sorry?
I got 90 at x squared at the end. Minus 9.
In the expansion?
Yeah.
10 choose 2 times by 2 squared.
Wait. 10 choose 2
Mm-hmm.
is 45, yeah?
And then 2 squared is, or minus 2 squared is?
Oh, I didn't think about that. Okay, I get it. Sorry.
Yeah. You got to be just so careful with those coefficients. But once you put it in the calculator, it's really, really, like, easy.
Okay, but is it not negative 100?
No, because you're doing minus 2 times minus 2.
Yeah, okay.
Any other questions?
Don't we need to show that it's correct 5 decimal places? But show that the real answer to 5 decimal places equals Carly's value.
Yes.
Okay.
Yeah, that's actually true. Yeah, that's a good. Yeah, absolutely. Yeah. So okay, what is the real answer? 0.998 to the power of 10.
I got 0.901790, and I just stopped there.
That 2, 3, 4. Oh, that's really awkward because it's not. It doesn't come out to 0.9018. It comes out to 0.90.
I said 0.98011790.
Oh wait, say that again. I miswrote your answer.
0.9801790.
Can you say it one more time?
9801790.
9801790. Thank you.
You're welcome.
Yeah, which then equals 0 point, and that's dot dot dot, which equals 0.9801825 dp. So yeah, they match. Happy days. Thanks for pointing that out, Ben. Yes. Yeah, you do have to explicitly state that the real answer, when rounded to 5 decimal places, gives the same answer as our thing. Don't know how Carly was doing the 1 minus 20 times 0.001 times 180 times 0.001 squared without a calculator, but that's her business, I guess. Cool. Number 9A. If there are no more questions. Given that f of x equals x squared minus 4x plus 2, find f of 3 plus h. Well, f of 3 plus h equals, rather than putting x squared, we're going to replace x with 3 plus h. And then I'm going to expand. So this first bit, it would expand to 9 plus 6h plus h squared. This bit simplified would be minus 12 minus 4h, and we've got plus 2.
So do you mind clarifying the the symbols, please?
Which symbol, sorry? Oh, this bit.
Mm-hmm.
Oh, okay.
Imaginary numbers.
Point. It means that B and C are integers. This little Z thing with the little double back thing means integers.
Okay, thank you.
Yeah, that's a good point. Thanks for pointing that out, actually. So when you simplify this, you get, okay, h squared. You've got 6h. And you've got minus 4h, which is plus 2h. 9 minus 12 is minus 3. And then plus 2 is minus 1. So you get h squared plus 2h minus 1. So that's what you get there. The curve of equation. Wait, any questions about the first part, first of all? Okay, 9b. The curve of equation y equals x squared minus 4x plus 2 passes through the points 3 minus 1 and the point q, where x equals 3 plus h. And we want to use differentiation from first principles to find the gradients of the curve at point P. So imagine you've got your curve and you've got one point, which is 3 minus 1. Well, differentiation from first principles requires that you use 2 points. So your other point, we can say, is going to be 3 plus a little bit more, namely 3 plus h. And then the y coordinate is going to be, well, when you put 3 plus h into y, notice how it's the same equation as before. So the answer to part A will be our y coordinate, h squared plus 2h minus 1. Then, differentiation from first principles basically requires that we find the gradient between these 2 points. So, but with a twist. We also include this limit aspect. So the gradient is the change in y. So h squared plus 2h minus 1 minus minus 1 is h squared plus 2h. All over the change in x, which is 3 plus h take away 3, which is h, which equals the limit as h tends to 0. H squared divided by h is h. 2h divided by h is 2. And then now we're in a position where we can actually substitute h is equal to 0. And that would give you 2. we can check this if you really wanted to, though this wouldn't count as part of your answer, by actually differentiating the way we know how. If you really wanted to do this, oh my gosh, dy dx equals 2x minus 4, and then substitute x equals 3, giving you 2 lots of 3 minus 4, giving you 6 minus 4, which equals 2. That's if you wanted to check. But this would not get you the marks. This, what I've written in red, is just a check. The bit in blue, differentiation from first principles, is how you would go about doing it. Okay, so let's go to number 10. I know this one was a bit of a long question. I will need help from people because, again, I do not have a calculator, so I need to know numbers. So it's asking us to plot values of log to the base 10 of y against x on the grid below. Conveniently, they've given us the table of values, so we're going to work out what these values are. So, could somebody please tell me what log to the base 10 of y is, i.e. log to the base 10 of 14?
1.15. 2 3 significant figures.
Okay. 1.15.
Then the next one is 1.65.
Okay.
Then 2.11.
2.11?
Yeah.
Okay.
Then 3.04.
3.04.
Then 3.11.
3.11.
And 3.53.
Okay. So we've got that. That's fine. Now we can use that to plot our graph. I don't know if people can still see that. In fact, let me make it full screen. Can I do that? Yep, I can. Okay, so for x, wait, does it go 1, 2, 3, 4, 5, 6? Yep, 1, 2, 3, 4, 5, 6. So I'm just going to plot. So when x equals 1, y is equal to 1.15, which is going to be, oh gosh, somewhere around here. When x equals 2, log of y is going to be 1.65. So that's like, wait, 1.2, 1.4, 1.6. It's like here-ish. When x is 3, log y is equal to 2.11. So 2.2 is here, so 2.11 is like here. When x equals 4, log y is equal to 3.04. So that's going to be somewhere here. When x equals 5, log y equals 3.11. So that's going to be like somewhere here-ish. And then when x equals 6, log y is going to be 3.53. So 3.2, 3.4, 3.6, so somewhere in between, like here. Okay, then the question asks, state with a reason which value of y is likely to have been recorded incorrectly. So which one do we think is going to be?
4.
Yes. This one, because the other points form a straight line, a linear equation. So, yeah, the y coordinate of 1,300 is likely incorrect. The other points form a straight line. And by it, I mean that, doesn't fit the pattern. So again, just covering my bases there. Then the next part is by drawing an appropriate straight line, find the values of K and B. First of all, what is K and B? Well, let's look back at the question. It says the student is told that the relationship between X and Y can be modeled by the equation Y equals KB to the power of X. Okay, so in terms of this, well, KB to the power of X. So what's the deal here? If they're saying by drawing an appropriate straight line, probably it means that we're using this straight line here, the blue things form. So is there like a tool that I can use for drawing straight lines? Shapes, insert line. Oh, this works. This works conveniently. Okay, so that kind of works. And what else do we know? Well, we can kind of think about this as a y equals mx plus c type graph, except it's not y along the y-axis, it's log to the base 10 of y. So we can say, rather than saying y equals mx plus c, we can say log to the base 10 of y equals mx plus c. So the bit along the vertical axis is like your y, which is your log to the base 10 of y equals mx plus c. Then to work out m, we just need to work out the gradient with the gradient of the line. So let's see. If I were to work out the gradient, I could use any 2 points on the graph as long as I'm not using the 1,300 mark. That's fine. So I'm just going to pick 2 and 3. So x is 2, x is 3, and log to the base 10 of y is 1.65 and 2.11. So 2, 1.65 is one coordinate, and my other one is going to be 3 and 2.11. Okay, so the gradient is going to be the change in the y, so 2.11 take away 1.65 all over 3 take away 2. If somebody could help me out, that would be much appreciated. 0.46 maybe.
Yeah, 0.46.
Okay, cool. Thank you. Thanks for that. So we've got the gradient is 0.46 because it's divided by 1. So we get log to the base 10 of y equals 0.46 x plus c. Now we need to work out what the c is. And we can do that by using one of these two coordinates. It doesn't matter which one. And just going to go for the second one. So if we replace log to the base 10 of y with 1.65 equals 0.46 lots of 2, because that's your x, plus c, we get the 1.65 take away 2 lots of 0.46, which is 0.92 equals c. That gives us what? 0.73. Is that right?
Yeah.
Okay, thank you. So our equation would be, just to make it easier for you guys to see, the equation would be log to the base 10 of y equals 0.46x plus 0.73. And then if we want to convert it into the form y equals something times something to the power of x, well, we need to undo the logs. So by making, by using exponentials, we can say y is equal to 10 to the power of 0.46x plus 0.73. Then, from that point, we have y equals 10 to the power of 0.46x multiplied by 10 to the power of 0.73, just using the index laws, but backwards. And if we write it in the form k times b to the x, well, that's going to be, what would that be? What would that be? Ten to the power of 0.73 times 10 to the power of 0.46x. But that's not good enough because they said b to the power of x. We have got 10 to the power of 0.46x. So we can say that that's equal to 10 to the power of 0.73 times 10 to the power of 0.46 in a bracket to the power of x, using again your laws of indices. So then and if this is the same thing as y equals k b to the x, that would mean then that k equals 10 to the power of 0.73, whatever that may be, using your calculators, and b would be equal to 10 to the power of 0.46, whatever that may be in your calculators. Are there any steps there that are unclear? Okay, moving on. Chris claims that for any given value of x, the gradient of the curve is always greater than the gradient of the curve y equals 1 plus 6x minus 6x squared. Show that Chris is wrong by finding all of the values of x for which his claim is not true. Okay, so we just go for it. We work out the gradient of both, and then we just determine where it's not true. So if we have y equals 2x cubed plus 6x squared minus 12x plus 3, well, the gradient is going to be got by differentiating. dy dx equals 6x squared plus 12x minus 12. And for the other one, we have y equals 1 plus 60x minus 6x squared. So we have the dy dx is equal to 1 plus, no, gosh, that's the lie. Dy dx is equal to 60 minus 12x. All good? By the way, I didn't actually stop to ask, how are you guys at this stage? Is everything making sense?
Yeah.
Yeah, I'm good.
Okay.
Yeah, it's all right. It's kind of hard though.
It is kind of hard. Luckily, I've got this recording as well.
Yeah.
The questions are not, they're not the easiest. That's for sure. So he says the gradient is always greater than the gradient of the other one. And we want to show that he is wrong by finding all the values for which the claim is not true, i.e. we want to find the values for which the red is greater than the blue. So we may as well say red is greater than blue. So let's let the gradient 60 minus 12x be greater than 6x squared plus 12x minus 12. Then if we take away 60 and add 12x to both sides, we get 0 is greater than 0 is greater than 6x squared plus 24x minus 12 minus 60 is minus 72. So I can divide everything by 6. So 0 is greater than x squared plus 4x minus 12. And conveniently, 0 is greater than x plus 6, x minus 2. And then by drawing a graph, remember guys, when you guys are solving quadratic inequalities, you always draw a graph. So if this were equal to 0, x would be minus 6 or 2. And we want it to be less than 0 or 0 to be greater than it. So when x is in between minus 6 and 2, that's when it's not true. Okay, I appreciate I'm going quite quickly, but if there are any questions, please let me know.
Okay. Oh, sorry. I didn't realize I was off.
No, it's all good.
I'm so sorry.
It's all good. Cool. Okay, a curve has equation y equals 6x root x plus 32 over x. Find dy dx. Okay, so first of all, we need to rewrite this. So y equals 6x to the power of 3 over 2, because this is x, and the other one is x to the power of a half. When you multiply them, you add the powers, it becomes 6x to the 3 over 2 plus 32x to the minus 1. So therefore, dy dx conveniently is going to be 3 over 2 times 6, which is 9x to the power of a half minus 32x to the minus 2. Done. Dy dx, 4 marks. Part B, the point A lies on the curve and has x coordinate 4. Find the coordinates of the point where the tangent to the curve at A crosses the x-axis. So we've got our dy dx. So at x equals 4, because it says the point A lies on the curve and has x coordinate 4, then we want to find the tangent to the curve at A. Dy dx equals 9 lots of 4 to the power of a half minus 32, 4 to the power of minus 2. That's going to equal, what's that? 4 to the half is 2, 9 times 2 is 18. 4 squared is 16 divided by minus 2. So that's equal to 16. So that's the gradient. And then our tangent is going to have the equation y equals 16x plus c. And if the x coordinate is 4, we can work out the y coordinate by substituting into here. So 6x root x plus 32 over x. 6x root x plus 32 over x. So if we substitute x equals 4.
Sir.
Yes?
I'm really sorry to interrupt you, but some of us have another lesson, so would it be okay to go?
Please do go. You guys will see this in the recording, so don't worry about missing it out. Have a good lesson, and I will see you guys on Thursday.
Thank you so much.
Sir.
Thank you.
You're welcome.
Recording.
You're welcome, guys. See you. So we have 6. Yeah?
Do you mind putting the recording in Google Classroom, please?
Yes, I can do that. No problem.
Okay. Thank you so much. Have a great day.
Awesome. Thank you. And you too. Take care. So we have 6x root x plus 32 over x. So 6 times 4 times root 4 plus 32 over 4. 24 times 2 is 48, plus 32 over 4 is 8. So that gives you 56, I think. So the y coordinate is 56. So we have 56 equals 16 lots of 4 plus c. And then 56 minus 64 equals c. So that's minus 8. So in actual fact, the equation is equal to y equals 16x minus 8. And if we look at where it crosses the x-axis, that's where y equals 0. So we say 0 equals 16x minus 8. So therefore, x equals a half. Any questions about that?
Do we then have to write the coordinates, or can we just put x equals a half?
No, you're absolutely right. So we have to write down the coordinates. Okay. So we'd have to write down a half 0 as your final coordinate, because it asks for coordinates. So yeah, another good point. Yeah, I was trying to go through this quite quickly to get through section A at least before ending. Did anyone have a look at section B at all?
I did the first 2 questions, but that's it.
Okay. Yeah, again, I wasn't expecting anyone to have finished, just because it is a full paper, and normally when you're actually ready for a full paper, i.e. you've done all your revision, they expect it to take, what, an hour, two hours maybe? An hour and a half? What was the time allocated for this? Okay, 90 minutes. That's 90 minutes after like your proper on it. Okay. Again, if people would like to see me do these questions, then I will go through them. The unit vectors I and j are perpendicular. Find the magnitude of the vector minus 20i plus 21j. So if we have minus 20i, well, that's minus 20 in this direction and 21 up here. So this is 20, that's the length of it anyway. And the length up here is 21. And we've kind of made like a little right angle triangle. And if we're asking to work out the magnitude of a vector, well, we can just use Pythagoras, which would be the square root of 20 or minus 20, it doesn't really matter. Either way, it's going to give you the same answer, squared plus 21 squared, which is, I don't know, the square root of something. 400 plus
841.
Ah.
That's the total.
It's 441. Thank you. Square root of 841, which I'm going to guess is 29, but yeah. Okay. Of the answers there. The angle between vector I and the vector minus 20i plus 21j. Well, we can work it out. So we know that our vector is way over here. And we can imagine I is along here. So we essentially want to work out this angle here. We don't actually need to work out what it is. I mean, you could work it out and then therefore deduce what's true. But we know that...
How do we know that it wants us to work out that angle and not the angle on the other side, the acute one?
Because it says the angle between vector I and minus 20i plus 12j. If you go this direction, that's minus I. It's going in the opposite direction.
Okay.
Mm-hmm. So yeah, even here, directions really matter. So given that this is 20 and that's 21, that would mean that this angle is going to be in between 45 and 90, which means that this angle is going to be... So if it were equal to 45, that would make this 135. So that means that because this is more than 45, that means there's less for this. So it's in between 90 and 135. is a kind of logic. But if you really, really weren't sure, you could just go ahead and work out what the angle is. I mean, this angle would be inverse tan of 21 over 20. And then do 180 minus that angle. And that would give you an answer. And then wherever your answer lies, that's what it's going to be.
That makes sense. Thanks.
Okay, cool. I'll go through this one as well then. In this question, use G equals 10. Okay, we have to use 10. A man of mass 80 kilograms is traveling in a lift. The lift is rising vertically. The lift decelerates at a rate of 1.5 meters per second squared. Find the magnitude of the oh my gosh. Find the magnitude of the force exerted on the man by the lift. So we've got the man's weight, which is 80 G newtons, and we've got this reaction force, which is which way is the lift going? It's rising. Okay. So if the lift is rising, that means that the acceleration is going to be 1.5.
If it's decelerating.
Sorry. Yes, you're right.
Okay.
Yep. The lift is rising vertically, but it's decelerating, which is a very, very good, very important point there. So if it's rising but decelerating, the acceleration is actually in the opposite direction. Yes. Thanks for that, Ben.
That's fine.
Yep. So we say that I guess we can pick up to be positive and down to be negative, just because I know that's what I've gotten to know, that's what you guys like. You guys like that consistency. So the resultant force is going to be R minus 80G. And that equals mass times acceleration, which is minus 1.5. So R is equal to 80 times minus 1.5 plus 80G. Minus 120 plus 800.
Yeah, which is 680.
Thank you.
Yay, I got it right.
Nice. Nicely done.
Thanks.
This question is actually this. Is it?
I don't know. I didn't get to it.
No, look at the question.
Yeah.
Look at it carefully. You noticed? You recognize it?
Yeah, I think we have done it.
Yep, it's the question that I gave you in the homework.
Okay.
Yep, and what's the next question? Okay. Did you want to look at this question for the force? Or do you need to go?
I think I'm going to go have my lunch.
Yes, go have your lunch, because otherwise you won't get time. What I would do is probably just answer this, and if anyone wants to watch the they'll see me answer their questions.
Okay, cool.
Awesome.
Also, what was the answer for question 11 again?
11?
Yeah, I think I missed it.
This?
Okay, yeah, I got that. Cool.
Yep. Nice.
Thanks.
That's all right. Yeah, well, if you have any questions, then of course let me know. Again, I saw that you posted yay when I changed the functions problem.
Yeah, I've done that as well.
You saw when you put, okay, cool. That was that. Do you know how frustrating that was for me when I saw that it came out as that? I was like, oh my gosh.
Mm-hmm.
When the answer dropped out to what it was, the functions problem.
Was it 0?
Yeah.
Yeah.
And I was like, oh my gosh. I mean, it was like satisfying, but at the same time, I was like, really? Maybe do all that work for that?
Yeah.
That was kind of how I felt. But it's good stuff.
I think it sort of made sense, because otherwise we would have had to work it out with 2015 for a 1-mark question.
Yeah, that's a big number.
Multiple choice.
Yeah. I mean, those questions then are not like exam questions.
Yeah.
They're UK Maths Challenge questions.
Okay.
Yeah, so, you can think about them as 1 mark questions, but you can also think about them as they're questions that are just going to require thinking regardless.
Okay.
Yeah. Yeah, I'll let you go have your lunch, and
Bye.
I'm just gonna finish writing. Take care.
You too.
Thank you. Okay, I'm just gonna pretend there are people here, so that when you guys watch this recording, you know, it's whatever. With this one, I would go through it, but given that that was in the homework and that you guys are working through it and that you guys got feedback, I will leave it. Of course, if there are any requests after watching this video, then let me know and I can go through it at some stage. A particle of mass 400 grams is moving initially at rest at the point O. The particle starts to move in a straight line so that the velocity v meters per second at time t seconds is given by v equals 6t squared minus 12t cubed for t greater than 0. Find an expression in terms of t for the force acting on the particle. Okay, well, if v is equal to 6t squared minus 12t cubed, then, and they want us to work out force, well, that's going to be, we're going to be using F equals ma. Then that's going to be telling us that we need to work out what acceleration is. So A is equal to dv dt, differentiating, which equals 12t minus 36t squared. And that's our acceleration. We need to multiply that by the mass. Remember, the mass is given to us in grams, so we need to change that to 0.4 kilograms. So force equals mass, which is 0.4 multiplied by 12t minus 36t squared, giving us, what is that? 0.4 times 12 is 4.8t minus 14.4 t squared. That's the expression for the force acting on the particle, because it was mass times acceleration. Okay, and then find a time when the particle next passes through O. Okay, so we just need to take our expression for v and make it equal to 0. So 6t squared, oh, actually, no, that's not true. Nope. Find a time when it next passes through O, because what I just said would imply that we're looking for when the velocity is next equal to 0, but that's not what we want. We want the time for when its displacement is actually at 0 or at O. So v is equal to 6t squared minus 12t cubed. V equals 6t squared minus 12t cubed. And then we want to work out the displacement. So that's integrating. So S equals the integral of v dt, which equals the integral of 6t squared minus 12t cubed dt, which equals 6t cubed over 3 minus 12t to the 4 over 4, which equals, and then we've got plus c. Always remember that plus c. That gives us 2t cubed minus 3t to the 4 plus c. Then we need to work out what that plus c is. The question says, oh dear, no, that's not the question. The question then says, it's initially at rest. So initially, meaning that at when t equals 0, at rest means v equals 0, but specifically at the point O, our origin, if you like, our s is equal to 0. So when t equals 0, s equals 0, so therefore 0 equals 2 lots of 0 cubed minus 3 lots of 0 to the 4 plus c, therefore c equals 0. So we can say that S is equal to 2t cubed minus 3t to the 4, and our constant is just equal to 0. And we want to look for when it next passes O, so we want to set S equal to 0. So that's 0 equals 2t cubed minus 3t to the 4. And then we're going to factorize t cubed. So it becomes t cubed times 2 minus 3t. So either t cubed equals 0, which means t equals 0. But we don't want that point. We want the next time when it is equal to 0. So, or 2 minus 3t equals 0, in which case we have that 2/3 equals t. So that's that. What are the questions that they're asking? Oh, okay. All right, I can go through this question, I guess. In this question, use G equals 9.8, okay? A van of 1,300 kilograms and a crate of mass 300 kilograms are connected by a light, inextensible rope. The rope passes over a smooth pulley as shown in diagram. The rope between the pulley and the van is horizontal. Okay, initially the van is at rest and the crate rests on the lower level. The rope is taut, the van moves away and pulls the lift, from the pulley to lift the crate from the lower level. The van's engine produces a constant driving force of 5,000 newtons. A constant resistance force of magnitude 780 newtons acts on the van. Okay, so we want to, no, that's not what I wanted. I don't want this. Go away. Okay, so draw a diagram to show the forces acting on the crate while it's being lifted. Okay, so we know that the crate has a mass of 300 kilograms, so we've got its weight, which is 300 G, and we've got the tension acting on the crate. That's it. And then next part is draw a diagram to show the forces acting on the van while the crate is being lifted. I'm just going to annotate the one here. So we're basically just doing the forces on the van, yes. So we've got the driving force of 5,000 newtons. There's a resistive force of 780 newtons acting on the van. And there's also the tension, same tension as the one that's pulling the crate up. Okay, then the next questions are asking us to show that the acceleration of the van is 0.8 meters per second squared, and then the other question is to find the tension. Okay, so basically working out tension and acceleration. Okay, so what would be the easier thing to use? I think the easier thing to use would be to use the crate, just because. Well, actually, we have to use both. Yeah, we can't get out of it. So using the fact that up is positive, down is negative, I know you guys like that. T minus 300 G is equal to the mass of the crate, which is 300 times A, it's accelerating upwards. And then our other equation from the van is going to be the 5,000, just saying that right is positive and left is negative, and also saying that up is positive and down is negative. 5,000 minus 780 minus T equals the mass of the car or the van times acceleration. So then that would give me what? Okay, this equation, I can say that T equals 300A plus 300G. So therefore, I can say that in this equation, I've got 5,000 minus 780 minus t, which was 300a plus 300g equals 1,300a. So I have 5,000 take away 780. I'm just going to use a calculator. I'm just going to use the phone one, I guess. Should do the job right. So that would be 4,220 minus 300a minus 300g equals 1,300a. And then, okay, so 4,220 minus 300g equals 1,600a. That's 1,300 plus 300, or 1,300 plus 300. And then a is going to be 4,220 take away 300g all over 1,600, which equals a. And we are hoping that equals 0.4. 300 times 9.8. Did I say 0.4? Maybe 0.8. Divided by 1,680. Yes, that comes out to be 0.8, which is what we wanted. And then we can use that to work out the tension. So recall with this equation that T was equal to 300A plus 300G. So T would be 300 lots of 0.8 plus 300G, which is lots of 0.9. If I substitute that in, I get 300 times 0.8 plus 300 times 9.8, which gives us 3,980 newtons. Boom, done. Okay, and then afterwards it says, suggest how the assumption of a constant resistance force could be refined to produce a better model. Well, the idea here is that the resistance force wouldn't be constant. You'd imagine that as the car accelerates, it gets faster, its velocity increases. Therefore, the constant resistance force might then increase as the velocity of the car increases. If you think about air resistance, for example, air resistance is likely to increase as the velocity of the car increases too. And that's it. How do I end this? Right, see you later, guys. If you have any questions, then just let me know the next time you have a lesson with me.